Hello everyone, and welcome to Jam Academy. In this example, we have a box of mass m dragged across a rough horizontal floor at a constant speed by a force whose magnitude F makes an angle theta with the horizontal. Now, if the coefficient of kinetic friction between the box and the floor is mu, at what rate does the force F does work on the box? We are required to calculate the rate at which the force F does work on the box. The very first thing that we need to do is draw the free body diagram that shows the forces acting on the box. But remember, there are some key phrases here. The box moves with a constant speed. That means that the sum of forces acting on the box is zero. In other words, the resultant force acting on the box essentially is zero. We know that the weight of the box acts vertically downwards, so this is mg. The normal force on the box acts perpendicular to the surface, so that is n. And kinetic friction acts in the opposite direction of movement, so that is f of k. Now, one more thing, if you look at the arrangement, you can see that you can resolve the force F into two components. You have the component parallel to the direction of motion, which is just going to be F cosine of theta. And you have the component perpendicular. This is going to be F, the sine of theta. So let's roll. Now, there are two ways that you can do this, the short way and the hard way. I'm going to show you the short way. Keep in mind that the average power delivered to the box by the force is equal to F, the component of the force parallel to the direction of motion, multiplied by the speed of the box. So this would mean that P is equal to F cosine theta multiplied by V. This is the short version. But the question is, what is F? What is F? In order for us to calculate F, we need to utilize the fact that the system is in equilibrium. That means that the sum of forces along the x direction, which is just going to be equal to F cosine theta minus f of k, this is equal to 0. In other words, f of k is equal to f cosine theta. Let's call this equation 1. Similarly, the sum of forces along the y direction, this will be equal to n plus f sine theta minus mg. This will be equal to 0. Yeah, this will be equal to 0. What this means is that that n will be equal to mg minus f, the sine of theta. By definition, f of k is just going to be equal to mu of k multiplied by n, which means that, remember, f of k is equal to f cosine theta. So this would imply that f cosine theta is equal to mu of k multiplied by n, which is mg minus f sine theta. Now we can expand the bracket and factorize out f. So we will have here f cosine theta equal to mu mg minus mu f sine theta. In other words, if we take this term to the opposite side, it becomes positive. So we will have here f cosine theta plus mu f sine theta equal to mu mg. If we factorize out f, this will be cosine theta plus mu sine theta equal to mu mg. We can divide both sides by cosine theta plus mu sine theta this will take care of that, and we will end up having f equal to mu mg divided by cosine theta plus mu sine theta. This gives us the value or the expression for f. Hence, the power delivered by f is equal to f cosine theta multiplied by v, which is just going to be equal to mu mg cosine theta multiplied by v divided by cosine theta plus mu sine theta. We can actually further simplify this by dividing both the numerator and the denominator by cosine theta. If we do so, we will end up with a beautiful equation. F will be equal to mu mgv divided by 1 plus mu, the tangent of theta. Right here, my friends, this represents the power delivered by the force F on the block. The power delivered by the force F on the block. Thank you so much. I really do appreciate your time. If you have any question, please do not hesitate to ask in the discussion forum below.